We want to continue our journey into logic by looking at conditional statements. And I want to show you what a conditional statement is with a little example here. Notice this, this statement we have over here. It says, if Sam is a poodle, then Sam is a dog. This is an example of a conditional statement. Now, with the conditional statement, you have the if part, which is the hypothesis, and you have the then part, which is the conclusion. So you have something like if P, then Q, or sometimes it's written this way. P, little double arrow, Q. We'll get into that more later. But this is an example of a conditional statement. Now, a lot of statements can be rewritten as a conditional statement. So, for example, consider this statement here. All birds have feathers. And let's suppose we want to rewrite that as a conditional statement. In other words, we need to write that as an if-then statement. Well, one of the ways we could do it is we could say, if an animal is a bird, then it has feathers. See, we rewrote this, all birds have feathers, as a conditional statement, an if-then statement. So that's something that's just an example of how that could be done. Now notice this next one. It says, two angles are supplementary if they are a linear pair. Now we just want to write that as a conditional statement. There's not a specific way to do it, but you need to communicate the same information with if-then. So what we do here is we say, if two angles are a linear pair, then they are supplementary. So that's one way that you could write that statement as a conditional statement. Okay, now we could look at some others here. We could say, okay, all 90-degree angles are right angles. Now you can think about, well, how would I do that? I would say, well, if an angle is 90 degrees, then it is a right angle. So that's one way you could do it, okay? Okay, so that's this one. Now we could look over at number 2. We could say 2x plus 7 equals 1 because x equals negative 3. Okay, so we could do this. We could say if x equals negative 3, then 2x plus 7 equals 1. Okay, we could do that. Number 3, when n equals 9, n squared equals 81. So we could say if n equals 9, then n squared equals 81. And you can see how this goes. I don't guess I need to do all of them, but these are examples of how you can turn a statement into a conditional statement. Okay, now, one of the things I want to point out about this statement, if Sam is a poodle, then Sam is a dog. This happens to be a true statement. So we could say, yeah, this is true. Now, conditional statements don't have to be true. You could say, if Sam is more than 6 foot tall, then Sam plays basketball. Well, that's not necessarily true, because not all people over 6 feet tall play basketball. Okay? So if you could say that. You could say, if Sam is over 6 feet tall, then Sam plays basketball. Well, that would be a false statement. That's not necessarily true. Okay? Because perhaps Sam doesn't play basketball. Okay? So not all conditional statements are true. You could have a false conditional statement. Now, what I want to do is I want to look at some of the terminology here. We can talk about the negation. Okay, we can talk about making something. Well, let's look at an example. The negation. Let's look at this statement. The ball is red. How do we negate that? Well, the ball is not red. Just put a not in front of it, in front of red. In other words, to negate something, you change if the ball is red to the ball is not red. Now, it can go the other way. You can say, the cat is not big. How would you negate that? The cat is big. See, so you can start off with the not, and then for the negation, you would get rid of the not. Okay? So this is an example. This is what we mean by negation. Okay? So, Tim made an A in the class. Tim did not make an A in the class. Okay? So that type of thing. So that's pretty intuitive, I think. Now, okay? Remember, we have this if-then statement. Okay? If P, then Q. So if we talk about the converse, okay? So let's think about this. So we could do this. We could say if P, then Q. Okay, this is a statement. The converse is going to be if Q, then P. Okay, so you exchange the hypothesis and the conclusion. So consider this. If Sam is a poodle, then Sam is a dog. Okay, the converse. If Sam is a dog, then Sam is a poodle. That's the converse. Now notice, this is an example where the statement is true and the converse is false. Okay, the statement is true and the converse is false. So you just need to know, okay, when we talk about converse, we're interchanging the hypothesis and conclusion. Okay, now let's look at the inverse. Okay, we negate both the hypothesis and the conclusion. So, if Sam is not a poodle, so notice we negated the hypothesis, then Sam is not a dog. Okay? That's the inverse. It's when you negate both things. Okay? The hypothesis and the conclusion. So you need to keep these straight in your mind. The converse, when we interchange the hypothesis and the conclusion. The inverse is when we just negate both. Okay? Now let's look at the contrapositive. It's the inverse of the converse. Okay? So you first exchange the hypothesis and the conclusion. And then you negate both of them. Okay? So you get the converse and then you negate both of them. Okay? So I guess I should look at the example here. So let's look at the converse. Okay? If Sam is a dog, then Sam is a poodle. Okay? That's the converse. Now, let's negate both of them to get the contrapositive. If Sam is not a dog, okay, then Sam is not a poodle. Okay, so notice I got the converse. Okay, here's the converse, and I negated it. There. Okay, so you've got your converse, your inverse, and your contrapositive. Now, let's look at this statement here. A conditional statement. If the measure of A is 30 degrees, then A is acute. Yes, that's true. I'm going to put a T there. Now let's look at the converse. If A is acute, then A is 30 degrees. The measure of A is 30 degrees. Okay, that's the converse, but notice that's not a true statement. That's false. Because A can be acute and not be 30 degrees. 30 degrees is not the only acute angle. Okay, now let's look at the inverse. Okay, if A is not 30 degrees, then A is not acute. Well, that's false. 31-degree angle, that's not 30 degrees, but it's still acute. Okay. So there's a couple of faults. Now, let's look at the contrapositive. Remember, I negate the converse. So if A is not acute, then A is not 30 degrees, is not equal to 30 degrees, the measurement. Now, that's true. If A is not acute, then it's certainly not equal to 30. So I would say that one's true. Okay? Okay, now, so those are some definitions. Now let's move on to this thing called a biconditional statement. Now, you'll know a biconditional statement because you'll see if and only if. Okay? So, think about, let's look at this statement up here. If two lines intersect to form a right angle, then the two lines are perpendicular. Okay? So this right here, if two lines intersect to form a right angle, then the two lines are perpendicular. Now, it's kind of defining what we mean by perpendicular. Okay? The intersection of two lines to form a right angle. So this is kind of a definition. Now, I want to show you something. We could write this way. I could change it. I could say if two lines are perpendicular, let me do this. If two lines are perpendicular, then they intersect to form a right angle. Now notice, that's the converse. So I switch the hypothesis and the conclusion. But both of those are true. Okay? Both of those are true. So I could just say, have a biconditional statement. Two lines, let's look at this biconditional. Two lines are perpendicular if and only if they intersect to form a right angle. That's the biconditional. And that's telling you two lines are perpendicular. If two lines are perpendicular, they form a right angle, their intersection. And it's also telling you if two lines intersect to form a right angle, then they are perpendicular. So it says both things. Okay, so that's the if and only if. It works both ways. Okay, so I've got an assignment down here for y'all to, explore some of these things and do a little practice.